Alright, and some of the problems that you'll be seeing on my math lab and potentially on a test next week are things where you don't have to expand the entire polynomial, especially when they get a little bit bigger, like a 10th power. It may just be too much to write out all those terms, at least for what we're doing. There are obviously times where that may be necessary. However, for us, and our purposes, it may just be the case that we want to find a coefficient on one of the individual terms of that expansion rather than the entire polynomial, just to save some time, at least to get the idea down. Alright, so what I do know is that the coefficient is going to be made up of three things. It's going to be made up of a number out of the Pascal triangle. It's going to be made up of a power of 2 and a power of 3. Okay, so every term is going to have a number from the Pascal triangle, a power of 2x and a power of 3 in it, and so the coefficient will just not have the x. It'll just be the part without the x. So what we need to do is first find the row of Pascal triangle that has a 10 as a second number. Well, in the last video we actually found the row with the 8 in it, so I'll just write that one down and we can add two more rows fairly quickly. So we had 1, 8, 28, 56, 70, 56, 28, 8, and 1. And so if I just add two more rows to that, let's see, 8 and 1 is 9, that's going to be a 36, 28 and 56 is 84. This is 126, that's 126, 84, 36, and 9 and 1. Okay, so there's the 9th row, or the row with 9 in it, and then we need the 10. So the next one is going to be what we need. That's 45, 36, and 84 is, oh, I just did times. 36 plus 84 is 120. 84 and 126 is 210. And then 126 and 126 would be 252. And then the pattern continues. So that's a 210, 120, 45, 10, and 1. Alright, so those are my coefficients. Now I only need the coefficient of x to the 5th. So remember, it's going to start at 10, with the first term starting at 10 and then decreasing. So start at 10. So 10, 9, 8, 7, 6, 5. So it's the middle term. So I want that guy right there, the 252. And then I want to make sure, so it's going to be 252 multiplied by the first term raised to the 10th. No, not to the 10th, sorry. Raised to the 5th. Times the second term raised also to the 5th. And the reason I know it's the 5th is because these two numbers have to add up to 10. Okay? So if I had put a 6 here, this would have to be a 4 and so forth. They have to add up to 10. And so I'm really looking for the coefficients. So the x isn't really what's important. I need the rest of it. So the coefficient is going to be 256, or I'm sorry, 252 times 2 to the 5th times 3 to the 5th. Okay, 252. Now 2 to the 5th is 32, and 3 to the 5th is 243. And so when I multiply those, 256 times 32 times 243, I get my coefficient. It is 195,9552. And if I put my commas in, that's 1,959,520, or 552. Okay, so that's my coefficient on the x to the 5th power. Okay. Alright, so that should conclude our talk on binomial theorem. Just kind of some cool things when you're raising binomials to powers, what the patterns are in the coefficients, and yeah, so just some really neat stuff there. I do hope you guys will take a little bit of time to kind of go through and maybe do your own little research on Pascal triangle and the binomial theorem and some of the cool mathematics that are related to it. Yeah, really appreciate you guys watching these videos and you know, getting all the way through to the end here. I'm looking forward to seeing how you guys fare on the last couple tests. All right, take care.